Using the ideas we discussed in Module 7, Investigation 1, we answered questions such as, if an angle theta measures 1.82 radians, what percentage of the circumference of a circle centered at the angle's vertex does that angle cut off? We reasoned that, because the measure of the angle is 1.82 radians, that means that it cuts off 1.82 radius lengths from the circumference of the circle. Also, because the entire circumference of the circle is 2 pi radius lengths long, the percentage of the circumference of the circle that the angle cuts off can be found by dividing 1.82 by 2 times pi. This tells us that the openness of the angle is 0.28966 times as large as the openness of one complete circle. So the percentage of the entire circle that the angle cuts off is 28.966%. In this investigation, we will use this information to determine the actual length of the arcs of the circle that are cut off by an angle. For example, in this problem, if the entire circumference of the circle in this problem is 15 feet, then how long would the length of the arc that's cut off by our angle be? Well, because the angle cuts off 28.966% of the total circumference of the circle, which was 15 feet, then the length of this arc is 28.966% of 15 feet. This means that the arc length will be 4.3449 feet. You will use these ideas to answer questions 2 and 5 in Module 7, Investigation 2. Submit your answers to all parts of questions 2 and 5 in Module 7, Investigation 2 in the student workbook using your instructor's preferred method by the time and date that your instructor has identified.